So we will start with the presentation. If you can't hear me, please leave me a message on the chat.
Yes, perfectly.
Perfectly. Thank you. Thank you very much. So once again, good morning. Welcome to this presentation of CYPE Connect Steel, the newest program of CYPE engineers. During this presentation, we will see 4 important points. So the first point that we will see is to try to answer the question, what is CYPE Connect Steel? The second one is the power of OpenSys. We will know about OpenSys and which is the function and the relation with CYPE Connect Steel, our new program. The third important point that we will see during this presentation is to know about the possible workflows. It's very, very important to know about the function of a program and which is the position in the possible workflow of a complete project. And at the end of this presentation, we will model a simple connection. During this modeling, we will see the different menus, the different tools that we have available on the application CYPE Connect Steel. This is the icon of CYPE Connect Steel, and answering the question, what is CYPE Connect Steel, we can say that it's an application for the designing and analyzing of steel structure connections using finite elements. This is the most basic definition of our program. This is the first goal of the application, the definition of a connection. So we have some bars arriving to a node, and the user will have some tools available in order to define the different components of this connection. We have the possibility to define plates, welds, and boards. And with all this combination and with this definition finite, we can also start with the analysis. This is the second goal of the program, to launch the analysis from a model of finite elements and obtain the results from the forces and stress, obtaining the checks and the verification of the different components. And talking about the analysis, we can say that the engine of this analysis is OpenSys. We will combine the application of CYPE Connect Steel with OpenSys. This is a very powerful engine, and for we can say that is a very interesting combination of two very useful tools. What is OpenSys? OpenSys is the acronym of Open System for Earthquake Engineering Simulation. This is a software framework developed by the University of California in Berkeley. So this engine that is a very powerful and will also in a very near future, have a combination with other software from CYPE. So the user can expect some change in software like Cyphercat and Cypher3D. And I think the very, very important feature of this combination is to be able to perform both linear and non-linear analysis. Let's get know about the workflow. We are talking about the position and the use of the application during the project phase. So we can see here on the screen and on this image the workflow for a project phase. So we can start in some cases with a CYPE architecture, our architectural model program. We can also start the project with the portal frame generator, or we can start with other programs or other formats. We can start with an structural model, and in IFC, we can also start with other structural models and other formats. All this information could be shared on BIM Server Center, our cloud. The second step is to manage this information and start with this information to define the structure. We can manage or do this task with Cyphercat, for example, or Cypher3D. Or this information about the design and the analysis and design of the main structure could be also made with other software. So for this case, we have the third and the fourth line. They obtain all this information by an IFC format or an AdriaBIM uploader. And after this step, we will share the information about the main structure and the forces with the BIM Server Center. And this is the time to use CYPE Connect Steel. In CYPE Connect Steel, we will import the information about the main structure, the forces. We will obtain the definition of the different connections. We can check this connection, and after that, we can share the information in a 3D model, the details and checks in reports of PDF, and share also the graphical information to manage and complete with the open BIM layout, the drawings and different formats, PDF, DWG, or DXX formats. This is the workflow from a point of view of project phase. If we talk about the workflow from a manufacturing phase, we can have for this purpose the application AdriaBIM Steel. This application, AdriaBIM Steel, is the application for the creation and maintenance of BIM models for structural steel detailing. So inside this program, we will integrate it also the steel, the CYPE Connect Steel. So add to the maintenance and definition of the BIM model, we will also be available to define the connection, to check the connection, and obtain in this final phase, the DSTV and the step formats for the manufacturer, the 3D models, the reports in PDF, and also the drawings from the layout and the drawings. You can, in this case, obtain different formats: PDF, DWG, and DXF formats too. So now we can see on the screen the complete workflow. We can see the project phase, and we can also see the manufacturing phase. The common point of these two different point of view, the project phase and the manufacturing, will be the CYPE Connect Steel integrated and in AdriaBIM Steel. So we can see on this workflow the complete different steps necessary to define the architectural, the structure, the connections, and obtain the final document necessary to the manufacturer. So we arrive to the example of today. We will, in real time, develop this simple example. We will obtain the node, we will define the different components, and we will launch the analysis. Between to do these different tasks, we will also know about the different tools and different features of the program. And in advance, we can see here the workspace that we will work with. We have, for example, for our program, a list of nodes. We will see also a 3D view of the main structure. And we will have a detail of the node that we are working on. Like a comment during this presentation, the microphone will be muted. So if you want to share comments or ask questions or share suggestion, please use the chat on the menu application. So let's begin. So this is the workspace of CYPE Connect Steel. I advance during the PowerPoint the workspace. We can see here the list of different nodes. We have also the 3D view of the main structure, and we can see the 3D view of the node that we are working on. So, and very important, how we can obtain the program. The program is available in BIM Server Center, our cloud, where we can see here the store. And from the store, we will have the CYPE Connect Steel. We have different information, the available languages, the version. We will have a website with documents and some videos to try to help for the training. And the user can also download the program from this menu. So this is the workspace of the program, and we have here the most basic tools in order to manage the files and the projects. In this menu, we have the codes, the available codes on the program. In this first version, we have two different codes available. We have the Euro codes and the EIE 2011, the Spanish standard. So we have a different coefficient from this this code. The user could also modify the different coefficient if it's necessary. We have also the libraries. We have the materials and elements. And for the different materials, for the section and plates, boards, and also for the anchors, the user can define, and we have some materials by default, but the user can also add materials and elements. For the elements, we have this menu. We have different types. We have also different patterns, and the user could also define his own profiles or modify the different elements that we have by default on the program. Talking about the different sections, for example, we have, for example, from the list of the nodes, in this case, we have the 3D view. And we can, for example, add a section to this node. So the user could edit the geometry that he have from the initial information. And the user can add different sections from the available section. The user can also define the section, material, and the layout, angles, and position. If we have, for example, a section defined in the program, we can see that in the 3D view is highlight the position of this node. This helps to the user to have an idea of the node that he is working on. And from this menu, connection, clicking on, we have the different menus, necessary menus to define the connection. In this case, it's already defined, but we have the different operations and the different necessary menus to add the components or modify the elements in order to define the connection. So we can, for example, add a plate. We can also adjust a section, trim a section. We have the operation end plate. We have the most simple task and the operations with a combination of the basic ones. So in this case, we have bolts too. We can add welds, openings, anchors, We have also the possibility to length the elements. We can modify the elements for the 3D view and also the analysis. We can measure, and we have some view options. We can also, for example, add the center axis. That is very, very important during the edition and definition of the connection. Immediately after that, we can pass to the sheet analysis. And here we have the generate from the BIM model, the load cases, loads, design options, and analyze. We will see other example of a connection. For example, this is very simple. We will go to the menu connection. We have so the different operations, the necessary operations to define the connection. And we can also select all. We have the original definition of the node, and we can check the different operations to see the process of the definition of the connection. So we have here the connection. When we finish this definition, we can pass to the sheet analysis. Remember that this example, all the information from this example is obtained from our program Cyphercat. So the different load cases are already defined, from this program. And in order to obtain only the most important combination, the user can define some characteristic for the aid of load case, for the analysis of load case and combinations. So the user can modify these conditions and obtain only the necessary or the most important load cases and combinations. For these load cases, we can modify the load steps that we will apply. Remember that we have a linear and non-linear analysis. We have the possibility to define a tolerance, the iterations, and the real terms. After that, we have the design options, and of course, we have the analyze. We will launch the analysis. During the analysis, we obtain first at all the discretization and finite elements. This information is sent to the engine OpenSys, and we obtain the results. From the results, we obtain color scale showing what's the percent of use of the different elements. We can see also, for example, from the result, the bond is stressed. And we can see also on the right of the screen the maximum usage from the different elements for the sections, plates, bolts, and welds. We can see the worst load cases for this maximum usage. We have the checks, and we have the detail of the checks. This is the list of the different checks. We can see the detail here on the bottom. And all these checks could be obtained on a report. This complete report could be obtained in different formats. We can export in PDF, docx, txt, HTML, or RTF format. We can see that we can export all this information on a PDF format, for example. So we can accept. And this will be our goal. So I will obtain this, this simple connection in real time for the next example. So how we can obtain this connection and all this information? I will follow the two simple steps from the workflow. So I will use the Cyphercat, our program for the design and analysis and design of structures. We have here a very simple structure on Cyphercat. Remember that we obtain from this program the necessary reports and the necessary drawings to define the project. We have, for example, here from an integrated 3D structure. For example, the different, we have the load, the joints, base plates, the analysis. We have here, and very, very important, we have the forces. Shear, bending, moments. We will also obtain from this program drawings and reports. We are talking about the analysis and design of the main structure. But now we can, or we need to define the connections. So for our case, I will share all this information on the BIM server cloud. So I will unlink, yes, and I will create a new project on BIM Server Center. So here I will create this new project. Type and the name 11 May. The type of project is a test. The view options visible in BIM Server Center, and this project will be open. So I can accept, and at the end of this process, I will export all the information. And this is very important. I will export the forces to design the connections. I can accept this export. The export is finished, and I have here my workspace on BIM Server Center and the different projects. And here I have my new project, Steel CYPE 11 May. This is the 3D view of the information that I shared with Cyphercat. I have the main structure and EFC format and different format, but the most important thing is I have the definition of the geometry definition, the definition of the section, and the forces too. Now I can go to the CYPE Connect Steel. I will go to the menu. I will define a new project. I will define a name for my project. And now I will select the project from the BIM Server Center. This is the project that I will use like initial information source. I will select the Cyphercat information, and the definition of the new project is working. So this is the initial point of my work with CYPE Connect Steel. So we have the list of the different nodes that the program recognizes from the IFC structure. And for the different elements, we will select, for example, a very simple node in order to see how we can work with. For example, okay, so this is my goal. This is the node that I want to define. So select the node. I go to the connection menu. And now we will start with the different operations in order to define the connection. For this case, it's simple. We can go to, in this case, end plate. This is a combination of different operations. So we will select the beam for the definition of the front plate. The joint 2, we will define the P1 like section and the bottom flange. We can select the material. We can also modify, for example, the thickness. For this example, I will use 14 millimeters, for example. We can modify, on this case, in this case, we can modify, for example, the dimension of the this front plate. I can add on the top and on the bottom too, for example, 15 millimeters in order to obtain place for the welds. For the connection between the beam and the front plate, I will use welds. The user can use a different type of welds. The user can also define different ways to measure this weld, different characteristics, and he can also define if the weld will be applied in situ or in workshop. The dimension of the thickness, and the user can also define an initial and final displacement. Can, for example, apply an initial and final displacement of 5 millimeters. We can see here I have also only 5 millimeters. Okay, we can see how this edition modify also the dimension of the welds, and we can add for this front plate some bolts. We apply the distance and the position in coordinates for these bolts. And I will copy this one to the end. And I can see the 4 bolts that I applied to the front plate. From the list, from the library, I can select the series of the bolts and the nominal diameter. We have the list of the library. The user can select the necessary, and we can define also the material, the space, and, for example, modify the reverse direction. We can see in the image, the different characteristics for the reverse direction. So we can define the connection. We can pass to the analysis. So we have the load cases. Remember, we have the forces and loads from the program Cyphercat. It's important to define for the equilibrium of the equations a bar with the characteristic of bearing. So in this case, we have the P1, the column, like a bearing bar, and for the beam, we will define the forces. The user have here on this image the help to see how is the what is the sense or the direction of the forces that he is applying. From the forces from the Cyphercat, the user can also modify or edit these forces. So for example, I can modify or add some load cases. The user have this right. And I will leave the default design options. And after that, immediately after that, I will launch the analysis. OpenSys is working now. The communications between the two programs is working on the process of the analysis, and after to receive the results from OpenSys, CYPE Connect Steel will offer us the reports of the different checks. We can go, for example, and select one element, for example, a bolt, or we can also select a weld, and we will see the different sections. We can also see the different checks, and also we can see the different elements. In this case, I start with the Spanish standard. I can change the standard, and I will use the Eurocode in order to obtain the check in English for the Eurocode. We'll go to connection. And now it's necessary to launch the analysis once again in order to apply the Eurocode. So we have the results. We have the checks. We can see also the von Mises stress. And all the information for these checks and the geometrical features and parameters could share in this case for the next step of the workflow. So remember, this is the first version of the program. It's very advanced now, but the users could also expect very interesting improvement for the next versions too. So the next Tuesday we will have a presentation with much more detail, and we will focus our attention on the analytical model. So you are invited for the next Tuesday to join us for this presentation. My colleagues during this presentation are answering the different questions or different comments on the chat. But if maybe an interesting question could be shared with the audience, my colleagues could, for example, send me the question and I will try to answer it.
Hi, Hernan.
Hi, Antonio. How are you?
Can you see they are very interesting of the implemented code or standard? Can you show in this first version the two standard we are implemented, and of
Yes,
course.
okay. On this in this first version, we have two codes, and the user can change the code in this first menu code, and we have here the drop-down menu where we can select the Eurocode or the EIE standard, the Spanish code.
Thanks.
Okay.
Okay.
Oh.
Do you have some tools to make measurement when you are making edition?
Yes, I during the edition or the definition of the connection, if we need, for example, to obtain some measurements in order to define the different components, we have this tool. It's measure.
Okay.
We can use the CAD reference, and we can obtain all this help on the screen.
Nice.
Okay, so
Nice.
we can obtain all this information from the different tools.
What about the local reference of element? Can you show it during the edition?
Yes, in order to obtain this information that is very important for the definition of the distance and the definition of the sense, the direction of the different components, we can manage the center axis here in this menu, view options.
Okay.
And we can see the local axis, and we can also, and this is important in order to make the view more easily managed, this filter. We can modify the type of 3D view for the section, plate, bolts, anchors, or welds. Okay.
Okay.
So remember, the next Tuesday we will have a presentation with the detail or the focus on the analytical model, and we will try to show during this presentation solve some other kind of connections. So you are kindly invited to join us next Tuesday. Thank you very much. Thanks for your attention and for coming. Bye.